Good morning, ladies and gentlemen. I feel I've run 50 marathons this morning already. I came in early just to check everything was working beautifully, and for some reason, my wonderful Lenovo 530, which has been wonderful, been reliable everywhere, decided not to clone the display. So I took it upstairs and I replaced the drivers, still not working. So I borrowed a little Dell device which cloned the display upstairs perfectly. And everything was going beautifully until I came back down here and things changed. So apologies for a few minutes late starting. I'm going to have an interesting thing doing the demos because the demos are going to be over there and I'm going to be typing over here, but we'll do our best, and that's what I shall try and do. Just in case you don't know me, I'm John Craddock. I work as a consultant out of the UK. I do a lot of work around the world. I specialize in identity. I used to specialize in AD. I specialize in integrating AD into lots of different environments. And basically, I think of it as crossing boundaries these days, because no longer do we have our little bastion. We have to reach out absolutely everywhere. So I'm going to cover today, I want to start off just setting what I consider to be today's access challenges. And that's access to things we want, which of course is data. I then want to look at Microsoft Federation Services and just have a quick look at an introduction to that. How many of you are using ADFS today? Okay, but that's probably just about half of the audience. And so I'm going to just ramp you up to speed on that, what's on offer today and what's on offer in the future. We're going to be looking at that in detail. We'll then have a look at how Windows 10, Azure AD, and also on-prem AD all fits together. And I want to cover briefly Microsoft Passport, because that's a very significant new technology from them. How many of you remember Microsoft Passport from many years ago? Okay, so for those, and it's probably about a third of the audience, just forget everything you ever knew. This is typical Microsoft. Oh, what name can we use? Oh, yes. What about Windows XP? Has anyone used that before? You know, so it's going back in time, reusing names. So the information I'm going to give you today is sort of current as of the 1st of February. Actually, it was sort of current after the last time I went through the demos, because I'm going to be looking to a certain extent at the Azure portal. And what you'll find with the Azure portal is that everything changes almost on a daily basis. So do bear in mind, though, particularly around the ADFS 2016, there will be some changes. I'm using TP4. There will be some changes before production, and there'll be some quite significant changes. So today's access challenges are that resources are absolutely everywhere. So we could have on-premise resources, and that's what we're always used for, that nice little bastion of AD, single sign-on to all those on-prem resources. And then came along the idea as well, actually it'd be really useful to push some of our stuff out into a data center somewhere, so we go private cloud. And then wouldn't it be useful to use some of those great SaaS apps? What about Office 365? Let's use that. Salesforce, and so on. So we've now got resources there. And then we're working with partners, so we've got partner resources. And of course, what I haven't put in there, but I include in the public cloud, are what I call social resources of kind. So our next challenge is we have our user, but what's changed on the user front is that user wants to get absolutely everywhere. And of course, what do they want to do? They want it to be SSO, all right? And what we're faced with in a lot of cases is a total proliferation of the user's password absolutely everywhere. And there's a huge number of users that use the same password. So if you manage to attack some app in the sky, it's quite likely you could get a user's password that's used on many different resources. And then the big game changers are the devices the users want to use. And the next thing is acting on behalf of. So we have one service that actually acts on behalf of a user and goes to another service, so goes to a back-end service. And we have multi-hop scenarios. And we need to be able to support all of this. From a user's perspective, the user is going to just want to be able to have no hassle access. No hassle access really means SSO. Sign in once, access to everything. They want to be able to use any device, and so they want to be able to use something at work, a tablet, something at home, their phone. So you're being driven by the user's need to be able to use any device in the workplace. And you might say, well, no, we're not going to accept that. But then, of course, the one game changer there is the CEO wants to do it. And how many of you actually told the CEO no? Ooh, 3 people, and they're all sitting next to each other. Are you on holiday currently? So the other thing is users want to feel safe, and therefore they are probably willing to make a little bit of extra effort to access what they consider as high-value resources. And what they consider as high-value resources are things like their bank accounts, etc. But do they consider your company resources high value? They certainly should do, and if they don't, there's an education issue there. Now, in terms of administrators, what they want is they only want to allow access for users and devices that they control. That's gone. It was nice to have. So the next thing is they want to allow access for trusted users. And that's very interesting because what we're going to do now is we're going to stand up a resource and we're going to allow access potentially for anyone, but we've got to qualify them because we're going to say anyone from anywhere on any device can come in. But we need to qualify them as, do we trust them? All right, so gone are these sort of bastion firewalls that protect and only allow certain devices in. What we're doing is we're coming to the stack and making an identity decision. So if you like, it's identity that becomes our new boundary, or identity and authentication that becomes the new boundary. And then we want to know that our data is secure and compliant. And what we'd like is to be able to have control authentication mechanisms and access mechanisms based on where the user is. So are they on corporate network, on the internet, are they in some partner organization? The device type and the state of the device. So we could have, a Windows phone, which we allow access to, and an iPhone that, the CEO's got that, we allow access to that as well. And we're also, are they compliant? So what we'd like to be able to do is measure the compliance of these devices and make a decision based on compliance. We also want to be able to make decisions based on application sensitivity. So we want to be able to mark an application, say, this is a sensitive application, we need a different authentication mechanism, and so on. And then we need to look at the user and the risk profile. So who is the user? And simplest way is, are they a member of HR? Are they a member of an admin's group of some kind? But in the future, what we'll be doing is actually analyzing their behavior. So if we can actually analyze and say, well, actually, do you know what? In the last 3 weeks, that person's used on and failed on their password authentication. Now, they are actually someone that doesn't normally fail on their password authentication. So next time they come in, let's make them do multi-factor. Right, so you can base it on what you assess as the risk on that user. In terms of managing authentication, where do we do it? The resource owner can do it. So we've got resources dotted all around the internet, and it's the responsibility of the resource owner to do that authentication. So what you've got to do as part of an agreement, when a user signs up to use an application, we need to provide identity information about that user, and we need to have a secret that the user has, i.e. we give them a username and a password. Bad news. All right, we'll see how Microsoft Passport will help solve that. The other thing to do is to say, actually, what we'll do is we'll use an identity provider which the resource owner trusts. So rather than the resource owner actually doing the authentication and managing the authentication, we'll push that out. And the trusted identity provider may be your own organization, right? Or it may be hosted by some third-party organization. And what we need for all this to work and to break down the boundaries is we need the appropriate protocols to drive all this. And this is where our federation protocols come in. And traditionally, the enterprise protocols were SAML and WS Federation, right? What did Microsoft really back? It was WS Federation. So WS Federation was in their Windows Identity Foundation stack. They've never really supported SAML on their .NET development. You can get third-party libraries to support SAML. But these protocols are still very, very much used. They'll be used for years to come. However, they're not what I would call innovative protocols, i.e. there's very little innovation going on with those protocols. Breaking away from the traditional enterprise protocols, there was a whole suite of protocols that have developed for internet use. And on internet use, we're using lighter devices. SAML is very heavy in terms of we have a beautifully declared security token, but it's in XML format. And we've got to parse that, we've got to generate it, we've got to check signatures on it, and it's heavyweight. But so for internet access, devices, etc., simpler protocols were needed. And there were all sorts of developments. It started off with OAuth, it started off with OpenID Connect, but where we've ended up now is we've ended up with OpenID. Started off with OpenID. What we've ended up now is OpenID Connect, which is about authentication, and OAuth 2, which is about authorizing one service to access another service on your behalf. So, how do we actually get there? And one of the things that is driven us, of course, with these simpler protocols is this idea of bring your own device. So if you're going to a REST API, how will you authorize to it or authenticate from one service to another service? You will do it using OAuth 2. So those have really become the de facto standard. So if someone's talking to you about, hey, we need to go federation, oh, let's use WS Fed, don't, all right? OpenID Connect and OAuth 2. Microsoft Identity Solutions, you've got Azure Active Directory, and it can provide authentication for users that are actually hosted in that directory. How do we get them there? Well, we can actually manually create them. We can create them from a CSV file, or what we could do is we could synchronize our on-premises directory into the Azure Active Directory. Azure AD actually supports all of the protocols that we want. So OpenID Connect, OAuth 2, and OpenID Connect and OAuth 2, they come in various flavors, all right, which are called flows, all right? And, you know, you've got code flow and different types of different flows, implicit flow, and so on. Azure AD supports everything pretty much. And then there's the really superb B2B and B2C services. So if you want to set up a site and you would like people to actually authenticate to that site using things like Facebook identity, LinkedIn identity, etc., what you do is you create an Azure AD, which is a B2C Azure AD. Right? It will then integrate and allow users to sign in with any of those accounts. And if they haven't got one of those accounts or they want to use a username and password, it will onboard them into the Azure AD. So now the identity is brokered by the Azure AD, and your application can actually allow access from all the social identities, plus, if people don't want to use that, an account that was automatically provisioned. And it does all of the provisioning, all of the sign up of the user. If you're interested in that, there's a session tomorrow on B2C, and also, actually I think it's tomorrow. Anyway, check it out. It might be today. I might have got that mixed up. There's also B2B, which is about one Azure Active Directory authenticating with another Azure Active Directory. And so if you've got two organizations that have got a presence in the Azure AD, they can authenticate between each other. So this guy can invite these guys to authenticate to an application. And if these guys don't have an Azure AD, it goes through an automatic sign-up process and gives them one. All right? So that's the B2B service. Now, if we're looking at doing it on premises, then what we need is Azure Active Directory Federation services. And an on-premises solution, so that's for managing federated authentication. It can be used as an IDP for Azure AD, so it can actually be used as an identity source to Azure AD. So this is very typical in the Office 365 space. Somebody goes to authenticate to Office 365, and what happens is they get redirected down to your on-premise Azure ADFS server to actually do the authentication. All right, and that's called Azure Federated SSO. So here, what's happening is on-premise is acting as an identity provider to the Azure AD. The current version is running on Server 2012 R2. Some people call it ADFS 3. Officially, it's not, and the product team like to know it as ADFS running on Server 2012 R2. So you can see why people call it ADFS v3. So the next release is going to be on Server 2016, all right, and currently that's in TP4, and there's many new features. Just very quickly, conceptually, because this is important to understand this, for those who are new to ADFS, what happens is a user will actually talk to an identity provider and say, I would like to access application X. And what will happen is that identity provider will actually authenticate the user, and having authenticated the user, will then craft a token specifically for application X. That token then gets passed to application X. Very similar in some ways to Kerberos. You know, if you want to go to an application, you're using Kerberos, you go up to a KDC and say, can I have a token to go to that server? The big difference is, you say, can I have a token to go to that server? And you get the same token, whether it's going to that server, or that server. Right? Kerberos won't work over, it's not supported as an internet protocol. But you end up with these huge tokens, even if you need very minimal information. Great thing about this is you're crafting a token specifically for the app. What's on the token? Anything you like, basically, and the token is signed. Just to show the flow on that, our user goes off to our claims aware app, says you're not authenticated, redirects it up to the IDP that the application trusts, authenticates the person against the Azure, the Active Directory in this case, generates a token, returns it to the client sends it to the application, and finally the application authenticates the token. Has to authenticate the token, it validates the signature, right, and then pass it back. Now, whether you're using WS-Fed, whether you're using OAuth OpenID, right, OAuth 2, it's a very, very similar flow. There are differences, but if you get that as a principle, that's really how it works for whatever protocol you're using. So ADFS today, what it does is it authenticates users against the AD, and that's your on-premise AD, and that's all it can authenticate users against. It produces a security token based on a set of rules, right? So and the rules are who's allowed to have a token, all right, and what goes in the token. It will accept tokens from other identity providers as proof of authentication of the user. So it can trust another IDP to actually sign a token and pass it down. And then it exposes endpoints. All the endpoints are talked to through over HTTPS. But there's endpoints for federation metadata, for WS-Fed, for OAuth 2, and so on. So that's ADFS as it stands today. if we go and have a look at what 2016 offers, it does authentication for users provisioned in an LDAP v3 directory. So we can actually hook up an LDAP v3 directory to ADFS, and we can authenticate users from that directory. Right? So there's been a huge request for this. And I've been involved in projects where we've had users in an LDAP directory. We've wanted to switch over to using federation. So it's forms-based authentication, users in the LDAP directory. We wanted to switch over to Fed. So we wanted to switch over to Fed. What we'd have to do is deploy AD, get our users into AD, put in ADFS, or go for a third-party security token service. So in some cases, we went for a third-party security token service. Now we can talk and hook in to that directory. The simpler upgrade. So previously, what you had to do is you had to build a parallel farm. Having built a parallel farm, you then had to migrate your data out of one farm, put it in another farm, and it was a mess. Now you can upgrade really nicely, and we'll look back at that in a minute. Delegated service administration. So now you can have an ADFS administrator, right, who is not necessarily a local admin on the box. But it also means local admins can't mess with ADFS. So we can actually have that segregation in there. The auditing was okay, but there was masses of events generated when you did something. So when you logged on with a user, created them a token, etc., huge number of events. Auditing is being cleaned up, so there's less events, but there's more information. And it's been schematized, so it's a lot easier to look at. There's also future support for Microsoft Passport, and I will come back on Passport. So if we want to do LDAP authentication, what we need to do is we can go to any LDAP v3 compliant store. And guess what? AD is a v3 compliant store. So if you have your ADFS with your domain, but over here you have another AD, and you don't want to set up any trusts between them, so it's a different forest, right? Isolated, maybe it's a DMZ forest or something like that. And you don't want to trust it by your AD. What you can do is now hook to it using LDAP. So we can actually authenticate users using LDAP in there. So what we need to do for that is create a local claims provider trust. So very easy. What we do is we create a connection. We define LDAP attributes for the claims mapping. And having defined those LDAP attributes for the claims mapping, we then create a new local claims provider trust. This code will be in the notes, which you'll be able to download, and this does actually work. What I like to do is if I put code in the notes, I've actually used the code to generate something. Right? So what that will do is it will hook ADFS to local AD as a claims provider. There's per application sign-in as well, which is another great feature. So what you've got with per application sign-in, we actually sign into ADFS. We can customize the portal, right? You've stood up an ADFS server in your organization for multiple business units. And the business units each want to publish their own applications. What they would like to be able to do is actually say, you know what, if you come to this application, I'd like it to look like our application when you sign in. And that's exactly what you can do now. So we can actually set it up so that we're going to, on a per application basis, we can customize the sign-in experience. And let's try, it's going to be an interesting experience doing the demo. It's like this, but we'll give it a go. So what I'm looking for down here is my 8.1 machine, which is there. So let's sign into this guy. So we're signed in, and what I'm going to do is I'm going to go to an application over here, which is called Claims 16. If I can see it, claims. There you are. Is that claim 16? Oh, no, that's OAuth. There we go. Maybe I should move my laptop onto the floor. Okay, so this is the view of claim 16, all right? So, but actually, this is not for claim 16. This is for the overall portal, all right? So whatever you're logging onto, whatever application, will look like this. If I actually go down on my ADFS server, so let's move over to my ADFS server, it's my domain controller, and move over to my ADFS server, log in there. Oops, sorry. What I can actually do is customize the portal itself. But before we do that, let's actually go and look at, once this is cooked, let's actually have a look at the ADFS console and see what we can see that's different in here. So ADFS management. So if we come down here, and what we've got is service up the top, the service node, and under there is attribute stores. The attribute stores are literally for claims augmentation, and nothing's changed there. So what you can do is, if you want to generate a claim for someone, you can go to Active Directory to get an attribute out of Active Directory. You can go to an LDAP store to get an attribute, or you can actually go to a SQL database. But that's not about authentication. If we go down to the authentication mechanisms, what we see here is we've actually got one sort of major change, which is if we edit that, we can actually see device authentication as a primary authentication mechanism. So it would be possible to say, actually, do you know what? If that device is authenticated, as in, do I know about it, and has it got a certificate that I've issued to it, I'm going to let that person come in. So you could actually have, for instance, a device that sits out on, the sales floor, which everyone actually can use to actually access information. And we could, and remember, we can change who can actually access things and what type of authentication mechanism they need. The other thing of note is, if we look at multi-factor, it's changed its name to Azure multi-factor. Previously, what we had to do is we had to deploy the multi-factor authentication server down onto on-premises, and what would happen is it would intercept between Azure and the request to authenticate a user against AD. Well, now what happens is it actually goes straight up to the cloud service. So what happened previously, it went through the on-premise and then went up to the cloud service, because the authentication is done through, or the multi-factor aspect, whether you get phoned or sent a text message or whatever, is done through the cloud service. So now we don't need to deploy the on-prem. If you get excited about this, think, oh, I'll try it out, that bit doesn't work at the moment, right? It's in private preview, so you have to do private preview for that. So if we cancel out of that, and if we go to this one, certificate authority, and you think, what? ADFS is a certificate authority. What on earth is it going to issue a certificate for? This is actually a solution to a problem. If you want to go to an Azure VM, a remote app, for instance, what you have to do is you have to log into Azure, and then having logged into Azure, you have to log in to the virtual machine. All right, because Azure is using Federation and the virtual machine is using Windows Auth. So there needed to be a solution. And the boffins sat down and scratched their heads and said, how can we solve this? And what the ADFS team said, hey, that's a Windows logon, Win logon service. It accepts certificates. So what we'll do is, when you log in as a user, all right, to ADFS, we'll generate a certificate that is trusted by the AD, which will allow you to log in to that service. All right, really nice. If you want to try it out, the Azure AD team have got their bit working, but the Azure team for the remote desktop service at the moment haven't done their bit. right? So it only half of this works. But the very interesting thing about this is if you want to go into your, let's say you're going through the proxy or going through ADFS, and then you want to go to a back-end Windows auth, you have to use Kerberos constrained delegation to get single sign-on. This would allow you to actually use a certificate to the back end and get rid of the need for Kerberos constrained delegation. So that's a really nice side benefit of this. All right? So what does it do? It generates a certificate which the ADFS server generates and is trusted by AD. Right? So, or what it can do is it can actually act as a registration service and talk to your on-premise issuing CA and actually issue the certificate, request a certificate from there and return it to the user. So really, really nice feature. So if we look at the certificates node is pretty much the same. It's a signing certificate, decryption certificate, the service certificate. Claims description, there are a few more claims, and I'll talk about those later on. Device registration service will eventually get retired. Where will you register a device? In Azure AD. All right? And again, I'll talk about that in a minute. Endpoints, the most significant change here is that we've now got OpenID Connect. All right? And OpenID Connect has, not only does it have the endpoints for authentication, although it doesn't say where those are, what it has is this thing called Discovery. And it's got OpenID Connect Discovery. And what Discovery will do is it will actually go here and ask for effectively for metadata. So if you're used to federation metadata, for those who've done WS Federation, and this is actually the metadata for OpenID Connect. So you can go there, it will give you back all the endpoints that are supported, and so on. Next thing is we got scopes, and scopes I will come back to in a minute, okay? And then the the proxy is just where the proxy gets hooked in. Access control policies, again, I will come back to those in a minute. Relying party trust, no real change there. Claims provider trust, you won't see at the moment anything in the UI, but if I'd actually run that script and added the ability to authenticate against an LDAP directory, it wouldn't, today, it doesn't appear in here. You have to look at it with PowerShell. Now, in release, I don't know whether it's actually going to end up here. It really depends whether they've got time to add it and show it. And then we got these things called application groups. And again, I will come back on application groups. But just to show you very quickly this customization, let's just fire up some PowerShell. And on my PowerShell, I've got challenging. Where are we? PowerShell. Think. Have that in. Custom PS1. Okay, and if we briefly look at custom PS1, and actually I can. Let's just go down here. So if I look at custom PS1 and just edit that with, sorry, let's not. Yeah. So what I've got is very, very simple. What you end up doing is you basically you set a relying party content, right, web content, and you can also set a web theme. And now if we go back, having done that, if we go back to here. Remember, that was my claims app. Let's just close that off. And what I had with my claims app, I literally just had the corporate log on. And there we are, claim 16. So now it's looking at claim 16. And what it's doing, it's saying, if you have a problem signing in, please call the claim 16 help desk on. It's got a phone number, or you could have the hyperlink. So now you're customizing it on a per claims basis. Okay. Where are we? Back to here. And actually, I put the size of your logo in your illustration if you want. And if you want to get fancy and you want to completely rewrite the page, you can rewrite onboard.js as the page. So, beyond relying party trusts are all about, basically, when you set up a relying party trust, you're saying this application, which you've defined as a relying party trust, trusts me, because me is the ADFS server, as an authentication provider, right, as an IDP. And what we need to do is in this trust here is we need to identify the backend server. So what we'll be doing is literally almost just having an identifier and also specifying a return URL. Because what's going to happen is we're going to access the application, and we're going to come up here, going to authenticate the user, and then we need to go back here. So the return URL is defined up here. Also, the identifier is defined here. So when we hit the app, it will say, go up there and ask for a token to me. Right? And the to me is its name. Up here, we'll need to define to me. Right? So we come up here. Can I have a token to me? And he looks in there. He says, "Oh yeah, I've got one of them." Generates the token. Oh, where shall I send it back? Oh, return URL's in here. Bam, back you go. Okay. Now, that's how relying party trusts work. That's still how they work, which is great. But when we come to OpenID Connect and we come to OAuth 2, life changes. All right? The idea behind OpenID Connect is that what we're going to do is we're going to bounce up to the server and say, please authenticate me to this guy. All right? Very much like a relying party trust. Right. And this guy is known as the client. So when I'm coming from my browser's not the client, and a web server renders back to the browser, the web server is the client. Right? So what will happen is it will redirect this guy up to the ADFS server and tell it to get a token for this guy to this client. So we need to identify the client. And if that was all it was, we could actually get away with that with a relying party trust. Right? But it goes beyond that, because now what this guy can do is on behalf of the user, he can request a token to a back-end web service. And what actually will happen is again, it will go up to ADFS, and if we gave it the token to the back-end web service, that would be potentially dangerous, because now the browser has the token which will allow it access to a back-end web service. So we could do that, and we could allow that to happen. But a better profile is to use the code profile. And with the code profile, what happens is ADFS gives back a code to the browser. The browser presents the code to the client, and the client goes back to ADFS and says, I've got this code, can I have the token, please, to the backend service? So now what we need is we need to define the backend service, so we need to identify it. We have to say how the client will actually authenticate itself to ADFS to prove that it is worthy of converting a code to a token. So we've got the authentication mechanism that's used. And then when we request a token to a backend service, what do we want to do with the backend service? So we define the scopes. And the scopes are things we can ask the backend service to do. So what we need to do is, in our request, know what scopes we're asking for. And for the backend service, we need to define what scopes are available. So there's a lot of things, and this is why relying party trusts no longer actually cut it for us. So we end up using things called application groups. And in an application group, we define the client, the front end, and we define the back end. Let's have a quick demo of this. And what I'm going to do is switch over to this guy. And I want to go to OAuth, which is down there. So I'm authenticating, and I'm going to authenticate as this guy called Jim, and he's at xtshub.com, which is the name of my Active Directory domain, and hang on, sorry. Jim at XT. If you can see better than I can, you probably can from the big screen, do shout. I just can't see down there. Where have I got my cursor? One to the right. Was there ever a television program in this country called Bernie the Bolt? And with XTS, thank you. Boom, boom. Right, that works. Okay. Can you just check I typed the password incorrectly? Okay, this is my little OpenID Connect and OAuth app I wrote just purely for this demonstration here. So what's happening, the first thing is, OpenID, we're going to authenticate, all right, against ADFS, and what we're asking for in that authentication is we're asking to gain access to this application. So this GUID is actually identifying the application. So who has just gained access? Well, it's our user, Jim, all right? So that gets that far. And then we've asked for a token to a back-end web service. And that token comes back as a JSON web token. And what I'm going to do is just Control-A that, and then Control-copy it. And I've got a little JSON web token decoder, which I'm going to use. And I'm just going to pop that in there. And what this is doing is saying, now the audience is the back-end service, which is my services, all right? And that's the back-end service there. The issuer is my sts.example.net. It's Jim, and I've got a whole bunch of claims for Jim, so I can actually augment this token with claims. But what have I actually asked for this token for? That comes under the scope. And right down the scope is saying OpenID, profile, user impersonate, and my check. What's my check? It's a scope I've defined. So what I'm doing is when I ask for this token, I'm going to get it with those scopes and present it to the backend server. And the backend service can actually check that that token's got the correct scopes before it allows me to do things. But you can see I've augmented it with claims so that we can do that as well. Now, if we go and look at the, if we actually go and look in here at the ADFS service, so coming over to ADFS, yeah, okay, let's go up here. So the scope descriptions is what we can ask for. And if you want to add one, you can. I've added up there is I've added my check. It's literally a text field, right? That the server wants, so the developer will tell you, well, I want to check these things are in the scope. And to be able to ask for the token with that scope, we need to define it in ADFS. And then what we've got is under application groups, I've got my one here. But what I want to do is actually go new application group. And what you've got is you've got client server applications, or you've got standalone. A native application, we'll just call this, is what's considered a public client. Oh, it'll do, whatever I typed will do. And what it's doing is it's just got a client identifier, right? This client is not going to go to a back-end server and ask for a code, all right? So it's just literally authenticating to this client. If we go for the next flavor, so we'll cancel that, and if we go for here and choose a server application or website, and we'll just call this, I don't know what we call it, web. Next on there. And what it's doing, client identifier again, return URL. Oh, I forgot to point out the return URL previously. So we'll just call it HTTPS return, it doesn't matter, .com, something in there. And so I'll add that in. And now what it's asking for is, okay, I'm going to return you a code, all right? But how are you going to authenticate against me to say, and me being the ADFS server, to say that I should change that code into a token? So one of the ways of doing it is with a client secret, which it automatically generates. You can use Windows Auth. So if your ADFS server is inside your domain and everything else, and you can authenticate against if your server and your ADF server are in the same domain, so you can use Windows Auth, you could do that. Then you don't have to worry about secrets or anything else, or you can actually use a certificate. So that's that bit. And then the final one in there is, if I go add application group, is this web API, and we'll just put in some rubbish in there. And what with the web API, again, we need a return URL. So https : .com will do. Anything in there will do. And then it's basically saying who's going to be permitted to access this application. So I'm going to say permit all. And what scopes does the application require? So this will be in the token request to get these scopes, right? So that's the thing. So you can see it gives you a little bit of an idea about how these application groups work, but they've been added to solve a problem. The problem being that OpenID Connect and OAuth 2 cannot be configured through an ordinary relying party trust. And rather than doing it in PowerShell in some convoluted way, we do that. So role-based access control. Role-based access control is based on user location. We've been through that. And they're managed through policy templates now. So rather than having to sort of set this up individually, we can use a policy template. And we can also measure device compliance. So we could, for instance, have a user with a device, and that now registers into Azure AD. It can automatically register into Intune. Intune then can, through MDA, which is the mobile device management, can report the health of that client into Azure AD. And then we use Azure AD Connect to write that information back into our own AD. And then ADFS can basically say, if you're compliant, I'll allow you in. If you're not compliant, I won't. Right? And so that's to be able to do that, we can use a 2008 R2 AD, but we need to update the schema for the is compliant attribute. Right? And also access can be revoked when the device goes out of compliance. Windows 10. Domain join ++. So when we join a device, a Windows 10 machine to the AD, right, as a domain join, it can automatically Azure join as well. So we can say it's managed, and we can measure its compliance and say whether it's compliant or not. So we've got that added feature. Actually, let's just have a very, very quick look at the, so I'm going to be working on here. Just very quickly look at these, because they're quite, if we look at access control policies, let's just take one here. So what you've got here is in your access control policy, down the bottom, it says permit users from device with authenticated trust level, i.e. the device is trusted. So if we apply this policy, we're going to permit users from devices with authenticated trust level. And then secondly, permit users and require multi-factor authentication except from devices with authenticated trust level. So any device that has authenticated trust level, permit. All right? Permit all other devices, all right, but make them use multi-factor, right? And we need to exclude the authenticated, so the authenticated aren't forced to use multi-factor. So you can create these, and then you can apply them to relying parties. And as you saw when I was setting up the application group for going to a back-end web service, I could say those, when I said permit everyone, it was coming out of an authentication policy. So we can apply those. Something to watch, and this is actually really interesting, is Microsoft Password port. If you think about passwords, they're extremely dangerous. We have our hacker, so phishing attack rings up, help desk here, and we need your username and password to test your account. Oh yes, it's Mary Jane and my password's, all right? And it happens an amazing number of times. Next thing you can do is you can go and steal the database on some web resource. And then you've got a complete list of username and passwords, right? And that happens a horrendous number of times as well. And then because users invariably use the same username and password for lots of different resources, right, you've got him. And then, of course, you can do the attack of the network, replay attacks, dictionary attacks, and so on network traffic. So passwords are very, very dangerous. So Microsoft Password port tries to get around this. The first thing it does is it uses a PIN. All right, and they say, oh, pins are safer than, actually some of the articles I've seen written, it says pins are safer than passwords, and people spend the rest of the morning scratching their head and say, how can they possibly be safer? The PIN unlocks a TPM, right? And if you use the Microsoft Hello framework, facial recognition unlocks the PIN, or iris scan unlocks a PIN on a Windows phone, right? Or a gesture or a series of gestures unlocks the TPM. So inside the TPM are stored resources that you want to go to, plus a private key, which is totally private to you, right? And a public key. So now what happens is when a user registers with a website, so there's Sam, this website already knows about John. When registered with a website, what will happen is we'll put the resource down. Number two, we'll generate a private key and a public key. And as part of the registration process, we will give that website the fact that it is Sam, and we will give them our public key, which I don't know why it says it's FF. It should be, the public key should be DD. So apologies for that. Bit of cut and pasting gone wrong, I think. And now we've got over the other side, what's that registration process? Exactly the same registration process where, you give a website your username and password, right? Or make it more complicated, all right? Have the fact that, they've got to do multi-factor, you verify their mail account. You get a third party to verify them, whatever you want, okay? Now, if we look at it, we log on Sam, send a challenge. It's a one-time challenge, so we can detect replay attacks. It gets signed. What's it get signed with? The private key, but it never leaves the TPM, right? And so it's signed with the CCC key, and then we validate it with the FFF key, which actually should say the DDD key. So again, apologies on that. No passwords anywhere, all right? Hack the user, do a phishing attack. Well, unless you steal their TPM and their device as well, you're not going to succeed, all right? Even if they gave you their PIN, it's useless to the attacker, all right? Check the network. Nothing of any real value is on the network. If you can't do a replay attack, because that challenge is a one-time challenge, all right? And if you steal the website's database, the data's useless to you. So we got rid of passwords, and we've solved a huge number of things. This is actually part of the FIDO Alliance standard. So in the future, we should be able to see more and more websites adopting this. And before you know it, you've got single sign-on because you just release your TPM chip, and away you go. It's in Azure AD today, and it's in, and not completely in, but almost in, sort of in, ADFS 2016. All right? Obviously, it will be in 2016 on release. So now, when we authenticate, we don't need to supply a username and password to get through ADFS. Single sign-on to everything. We don't need to supply a username and password to get to Azure. It just uses PIN authentication. I told you the upgrade was very simple. So basically what you do is you upgrade individual ADFS servers, and you're running at 2012 R2 farm functionality level. When you've upgraded them all, you transfer the master to one of these guys, all right? And then you raise the level. So you go over to a 2.16 farm. In terms of schema updates, you need to update your schema. If you are going to be using things like the compliance attribute, you need a 2016 domain if you are going to be using Passport, right? So the requirement of that is that you will need a 2016 domain. And then, the WAP basically stays there, and when you're ready, you just upgrade the WAP. And that sort of takes you through what we've got to offer in the actual ADFS space, and also in the Passport space. In terms of the web application proxy, there's no real changes there. There's a few nice to haves, such as you've got HTTP to HTTPS redirect, and there's better support for publishing HTTP basic auth, etc., and the Microsoft Office authentication. So better support for that, but really there's no major changes in there. So what have we seen? There's a lot in there to solve today's identity challenges. So making it easier to work with distributed resources. In particular, if you don't want to go down the federated route, you've got the ability to have Microsoft Passport, so your applications could sign up to Microsoft Passport. And yes, despite my angst before we started, it all seems to work quite nicely. So all that's left to say is thank you very much for coming to the session, and thank you for allowing me to start a couple of minutes late. Thank you very much. And if you've got any questions, by all means, come down and ask, but I need to clear up so that I can leave the desk clear.